Hello, algebra students. This is the 5.1, 5.2, 5.5 review that we did before break. So we're just going to go over it here in this video just as a review. So number one, you raise this entire quantity, okay, to the third power, okay? And so you multiply the exponents. And remember, you've got a sort of unspoken exponent of 1 on the 6, or unwritten exponent of 1. So that's 1 times 3 is the exponent that's going to go on the 6. So that is going to be 6 to the third. And then you also do each of the others like that. So you have exponent of 4 is on a, right? So a to the what? 4 times 3, right? Multiply that times that. So 4 times 3 is 12. And then b, well, what's the exponent that b ends up with? Well, it has this 1 that we don't write down, but it's always there. So 1 times 3 is 3. And then for c, it's c to the 5 times 3 power, 15. And don't leave it like that though, because 6 to the third power, we can calculate that, and it's 216. So as the final answer, you'll have this. Okay? Okay, let's go on to number 2. Now this is a division, so we subtract exponents, okay? Look for the same variable and subtract the exponent. So we have 4, and there is no 4 in the denominator, so there's nothing to do with that one. For x, we have 2 in the numerator, 3 in the denominator, so we subtract exponents. Okay, so that's x to the minus 1. Now it says our answer should contain only positive exponents, so we're going to deal with that negative exponent. But for now, we'll just leave it there. Then there's going to be another step where we'll deal with that. So if we look at the y, we have a 2 and a 6. So that's 2 minus 6, and that's negative 4. So we have y to the negative 4. And then for z, there is no z in the denominator, so it's just z to the 4th. Okay, so that's the intermediate result. Now, you have to deal with those negative exponents. If it's a negative exponent, then you put that variable in the denominator and the exponent becomes positive. Okay, so let's go through this. 4 stays in the numerator. When we get to x, it goes in the denominator and the exponent becomes positive. We get to y, it goes in the denominator and the exponent becomes positive. Z stays the same. It was positive, so it stays in the numerator. Okay, so that is the answer. Now the 1 right here that I have, we don't have to write that. You could write it or you can not. It doesn't matter. Either way is fine. Okay. Another way to look at this is you could say, well, for x, for example, the exponent in the numerator is smaller than the one in the denominator. So we'll take 3 minus 2 and get 1, and it will be in the denominator, okay, as a 1. So you could do it that way as well. With y, you have 6 and 2 as exponents. The denominator is the bigger one. So 6 minus 2 is 4, and it's in the denominator. So you get the same thing either way, okay? Okay, so let's look at number 3. Anything raised to the 0 power is 1, so that's a real easy one. It's done. Look at number 4. We're now multiplying, so we add exponents. Number 2, we were dividing. We subtracted the exponent in the numerator minus the exponent in the denominator. But 4 is multiplying, so we just add exponents. So we multiply the numbers, so negative 6, okay, times 3, that's 18. I'm sorry, negative 18. Okay, we look at our x. Well, we have x to the fifth. There is no other x in there anywhere, so it just stays x to the fifth. Okay, we look at the y. We have y to the fourth, we have y to the fourth. Add exponents, that's 8. Okay, so you have y to the eighth. Z to the negative 1, z to the seventh. Add exponents, that's z to the sixth. Whoops. Okay, so that's your answer for number 4. Okay, let's see. I want to have a circle there that I don't want to leave. Okay. It's actually a little bit of a mess. So I got my answer right. I have to make this eraser smaller to try to get that off of there. Okay, may not be the quickest way, but we'll do it. Okay, got it. Sorry about that delay. Okay, so let's go on. Number 5. So we're multiplying again, so we add exponents. Okay, no parentheses this time. That's okay. It's a very similar problem, really, to number 4. But number 4 had some parentheses, but multiplication, parentheses don't really matter anyway. Because in multiplication is associative, right? The grouping doesn't matter. We could put some parentheses, for example, in here. Wouldn't matter, right? The grouping does not matter in multiplication. Of course, the parentheses in number 1 matter a lot because you're raising that whole group within the parentheses to the power 3. So exponentiation is happening to that entire thing in the parentheses, so they matter a great deal. So looking at number 5, we're going to multiply, and so we just look for the same variable and add the exponent. So we have a u here, and it's to the 4th power, and it's to the 2nd power, so we add those exponents. So we have u to the 6th, and I'm going to go ahead and write down the 3, okay, because it's nothing to multiply it by. So 3u to the 6th, and we have v. Well, v to the 2nd, and what's the exponent here? It's not written, but though if it's not written, then it's 1, right? So you have 2 plus 1. So that is v to the 3rd. Okay, and that's it. Okay, go on to number 6. We have the same base. Now this time it's a number, 16. But it's the same base, and so we subtract exponents. So the exponent is 4 in the numerator, 3 in the denominator. 4 minus 3 is 1. So you could write it 16 to the 1st power. Of course, you could just write 16. Okay. Let's go on. Simplify each expression. So now we're adding and subtracting. And all you do here is look for like terms. Like terms have the same variable raised to the same power, and you combine them. So we look at this 7b cubed, and we look for another term that's b cubed. And see, there are not any. There's a b squared, there's another b. There is no other b cubed. So this is very important, and it's a very common mistake to try to add 7b cubed plus 2b squared. Well, those are not like terms. You cannot add those. You cannot combine them. The only thing you could combine with 7b cubed is some other term that has b cubed. There are not any, so that stays just 7b cubed. Now what I do is then I cross that off, okay, meaning I'm done with b cubes. I'm done with that term. I don't have to consider it anymore. So now I like to do these in order. This by the power, descending, looking at the power and then doing them in descending order. So our biggest power was the 3, right? So next biggest is the 2. And we'll end up in standard form if we do it this way. This says simplify each expression. It doesn't say you have to do it in standard form this time, but sometimes it might. So we might as well do it in standard form, which means the higher powers first and then you keep going down. So b squared is the next highest, the one with the next highest power. So we have this b squared, and there's no other term with b squared. So that is just minus b squared, minus 2b squared. Now notice I have the plus here, and then I have minus. So that's a little awkward. We don't have to write it that way. I'm gonna erase all that. It would probably be better to just write minus 2b squared. Or you could say plus negative 2b squared. Either way is fine. Okay, now we get to the next, and we'll cross that off. Now the next one is 7b, and we have a negative 7b over here, but we also are subtracting here. So of course we have to distribute that subtraction. Okay, so we have 7b and we have minus. This minus is distributed. Okay, so it's minus negative 7b, so that's plus 7b. Okay, so make sure you catch that. So that's positive 7b here, and it ends up being plus another 7b, so that's plus 14b. Okay, and let's cross those off. And now we have plus 8, and remember the minus, this subtraction is distributed to everything within the parentheses. So parentheses are very important in this problem. So we're distributing that negative and taking minus this negative 8. So that's positive 8, right? So it's 8 plus 8, so that's 16. And then now we've got everything crossed off, so we know that we're done. And we have all the like terms combined, so that's our answer. Okay, let's look at the next one. This is just a plus here, so we don't have to worry about distributing a subtraction across all of the terms inside. We just combine the like terms. I'll look for the largest one first, so that's m to the 4th, and there's another m to the 4th. Okay, so let's combine those. Negative 7m to the 4th, negative 2m to the 4th. That's negative 9m to the 4th. Okay, and those go away. We combine the next one. The next highest power is this right here, the 2. And there's nothing to combine that with. So that's plus 6m squared. Okay, and then we have the next one is 5m, nothing to combine it with, plus 5m, and then we have plus 3. And, oh, sorry, that's not all. We have 3 and we have 7, so that's plus 10 when we combine them. 10. Okay, negative 9m to the 4th plus 6m squared plus 5m plus 10. Okay, so next we're going to multiply. Multiply some polynomials times each other. So the first one is just this monomial, negative x cubed plus this, or times this polynomial. So this is just distributive power. We're going to take like this. Okay, so let's do that. We have negative x cubed times 5x squared. Okay, so to multiply, the number is just 5 times, well, negative 1. You have 5 here, and really negative 1 is the number that goes with x cubed. So we multiply the numbers, and so that's negative 5. And then we take x squared times x cubed. Well, that's when we add exponents, right? So that's x to the 5th. Okay, so the next one, again, we have the negative 1 times, in the case of this, the coefficient is just 1. So that's negative 1 again out front. And x cubed times x to the first power. Remember, that's x to the first power. So you add those exponents. That's x to the 4th. Okay, so now we take the negative x cubed times 2. So the number is just negative 2, and we multiply numbers, negative 2x cubed, like that, and that is the answer. You have to look at the end then to see, can we combine like terms, and there's nothing to combine here. Okay, so that's it. Okay, so let's look at this one. Now, this is the familiar binomial times a binomial. We've done this before, so this is like FOIL. So we're going to take that times that, and that's 10r squared. Okay, add the exponents, right? That's like a 1 and a 1. So we add them together, get 2. Okay, so then we take this times this. Well, the 5 times 8 is 40. And an r, right? Because we just have that single r with the power is just 1. Then we take the negative 4 times the 2r. Well, that's negative 8. Negative 4 times 2, negative 8. And then the r, that's the only r there. And then this negative 4 times 8. And that's negative 32. Now, you do have to look and see, can we combine like terms here? Yes, we can. So you get 10r squared. And you have this, 40r minus 8r. So that's plus 32r. Okay, and then you have minus 32. And that's it. Okay, so that one's finished. Okay, let's look at this these last two multiplications. This one is a little more involved because you're going to take this times the first term in that first binomial times each of the terms in the trinomial. Okay, and then you're going to take the second term in that binomial and take it times each of those terms. And then when you're done, look at all the combine all the like terms. So here we go. 6n times 4n squared, that's 24n squared. 6n times negative n, negative 6n squared. 6n times negative 3, negative 18n. And then we take the 2 times everything. 2 times, or sorry, negative 2 times each thing. Negative 2 times 4n squared, negative 8n squared. Negative 2 times negative n is positive 2n. Oh, I made a mistake here. Wait a second. No, I didn't. Negative 8n squared plus 2n. Yeah, that's right. And then negative 2 times negative 3, that's positive 6. So now we got to combine like terms. And we see, oh, we should have had an n cubed here. Sorry, I made a mistake way back there. And maybe you caught that. You were hoping I would catch it, or maybe you were hoping I wouldn't. This should have been n cubed here, right? This is 6n squared or sorry, 6n times 4n squared. And so let's write that better. That's 24n cubed. Okay. So now we can combine like terms. There's no other n cubes anywhere. So we have 24 n cubed. Cross that one off. We look for the n squareds. Well, there's 6 minus 6n squared and minus 8n squared. So that's minus 14n squared. Cross those off. And then we look at the n's. We have negative 18n and plus 2n. So that's negative 16n. So we can cross those off. And when we have 6 is the only thing left, plus 6. Okay, so that is the answer. Okay, we have 24n cubed minus 14n squared minus 16n plus 6. Okay, the last one is similar. So we're going to take the 7n and we're going to take it times each of the things in that second trinomial. So that's 56n cubed, and then that's minus 56n squared, and then that's plus 7n. Okay, and that's the 7n times everything. Now we look at the 6, and we take it times each of those that's in that second trinomial. So you have plus 48n squared minus 48n and plus 6. Okay, now we combine like terms. 56n cubed is the only term that has the n cubed. For n squared, we have this negative 56n squared here, and we have the 48n squared here, and that is negative 8n squared when we combine those. Okay, and then so we can cross those off. For the n, we have the 7n and negative 48n. Combine those, we get negative 41n. So we cross those off, and then we have, all that's left is the plus 6, and that's it. We've got that one done. Okay. So let's look at the second page then. This says, write each polynomial in standard form and then name each polynomial by degree and number of terms. So writing it in standard form means in descending order by the exponent on the variable. So we need to rearrange these, and the largest exponent is the 4. Okay, so that's going to be 3p to the 4th we write down first. And then, well, the next one is this 3. So that's going to be next minus 3p cubed. And then we can kind of cross these off too as we go to make sure make it easier to tell what's next. So next we have 10p squared, and then we have plus 4p, and then we have minus 8. So that is standard form. Now, a lot of you guys, when you did these, you missed that part of the problem, and I didn't count it wrong because it was I just let you off on that. You're supposed to write these in standard form and then name each polynomial by degree and number of terms. So these names are on the notes, and when you have the degree is 4, there's a special name for that, and it's called quartic. So how do we know the degree of the polynomial is 4? Well, that's the largest exponent. Okay, so look at that first term. Once you've put it in standard form, you have them in descending order. You know that that first term is the one that has the largest exponent. So it's 4, and so from the notes you know that's called a quartic. Look at the degree and then just got to memorize these names, okay? And there's not that many to remember. So it's quartic, and then you look at the number of terms. And anything that has this many terms, okay, that's just a polynomial. Okay? So once it gets over 3, you just call it a polynomial. And this has 5. Okay, so the next one, let's put this in standard form. Okay, so x squared is the first term, and then you have minus 8x, and then you have minus 10. And when the largest exponent is 2, what you have to memorize is that's called quadratic. The degree is 2, it's quadratic. And this has 3 terms, so it's a trinomial. Okay, this next one, it's already in standard form. We could write it down again. That's it. And when the largest exponent is 1, again, we could write that 1, or we don't have to write it. That's called linear. And when it has 2 terms, it's called a binomial. So by degree, it's linear. By number of terms, it's binomial. Linear binomial. And the last one, okay, that's actually a polynomial. Very simple polynomial. It's just a number. In standard form, you just write it exactly the same. There's only one term in this polynomial. So there are no multiple ways to write it. You can't change the order when there's only one term. It's just that. So what do you call this? What is its name? Well, by degree, the degree of this is, you'd actually say 0. You could write x to the 0 here, right? Because x to the 0 is 1. So that 3 times x to the 0 is just 3 times 1, which is 3. So when you don't have a variable at all, we'd say the degree is 0, and that's called a constant. That's just something you have to memorize. Constant monomial. It's a monomial because there's one term. Whoops, nomial, yeah. Okay. So last is these ones we have to describe the end behavior. Now, all you look at is the first term when it's in standard form. That tells you everything you need. If you've got it in standard form, that means you've got that highest exponent term first. Okay, so that's the one you're looking at, the term that has the highest exponent. You just kind of ignore the rest when you're describing the end behavior. End behavior means, what does this do as you go really far to the left into negative infinity, you might say, on the x-axis. When you go all the way to the left on the x-axis, what does the function do? And for polynomials, it's always going to either go up, up, up to infinity, or it's going to go down, down, down to negative infinity. Okay, that's what the function's going to do when you go to the left, and it's going to do one of those two things when you go to the right. And end behavior means, well, which one does it do? So you look at that term. Again, you can ignore these others. This is in standard form, so our biggest exponent is 5. And the rule for this one is when that's odd, you look at the is it even and odd, or odd, the exponent that is, and you also look, is it negative or positive? Okay, is the term itself negative or positive? And so if it's negative and it's odd, what that does is, when you go all the way to the left, it goes up, meaning infinity. And when you go all the way to the right, it goes down, meaning negative infinity. Okay, so I'm going to write that a little bit better. Okay, and the way we put that in the notes, we call this down and up, meaning all the way to the left, your function is going down. But when you go all the way to the right on the graph, the function, I wrote that backwards, sorry. Sorry about that. Up and down. When you go all the way to the left on the x, the function is going up. And when you go all the way to the right on the x-axis, when your x, that is all the way to the right to a very large positive number for x, the function goes down to negative infinity. Okay, so these are the two ways of writing it. And what that means for the graph is when you're all the way to the left, the function is just going up very big, like that. And then when you're all the way to the right on the x-axis, the function is going down, down, down. And you really don't know what it does in the middle. And that's what we're going to be learning about next, and how to graph these things. But when you go far to the left, it goes way up. When you go far to the right, it goes way down. And we know that, again, because we're looking at the exponent and we're looking at the sign. Okay? And we show that behavior with one of these two notations, and this is the one that we'll probably be using most of the time. Okay? So let's look at the next one. The power is even this time. We just look, is it even or odd? And the sign is negative. So in that situation, okay, we write down and down, or in the other notation, when you go all the way to the left, it's negative infinity, and then as you go to the right and keep going, it's also negative infinity. Okay, so I'll just do one more this way. If we were to graph this, we don't know yet. Based on based on these considerations, all we're going to see is end behavior. But at the end, when you go far, far to the left, this thing goes down. And when you go, it's going down really steep, and it just keeps going. And when you go all the way to the right, it also goes down. And it does something in the middle. Okay, and this was a parabola, so this one's pretty simple. We know what it's going to be shaped like. But the end behavior considerations that we're using, looking at that exponent again and looking at that sign, they only tell us the end behavior. And so, whoops, this is the end behavior. Okay, and then it does something else in the middle. Okay. So, look at these last two. What's the end behavior of this one? Oh, it's, look, just like the other one. We have an even exponent and we have a negative term. So it's going to be the same. When we're coming from the left, we're looking at this at the left side. It's the function value, we might say, is negative infinity. And the function, when we go all the way to the right, is also negative infinity. Or we could call that down and down, is the other way of saying it. And then the last one up, I've already got this one filled in, so no drama on this one. When it's even and positive, it's positive infinity on the left and right. So we write it this way. We could write that also up and up. Okay, so that is all. We'll see you later.